Welcome to my channel, dear students. So let us quickly see the rest of the questions, and the first question for the day is question 36. So it says, using ruler and compass only, construct a parallelogram ABCD using the following data. That is, AB is given to be 6 cm, AD is given to be 3 cm, and angle DAB is given to be 45 degree. So this is the first part. Second part we'll look later. Okay, so this is your rough diagram. AD is given to be 3 cm, AB is given to be 6 cm, and this angle is given to be 45 degree. Okay, so let me quickly construct my parallelogram. Okay, so here I have taken AB to be equals to 6 cm. Okay, from the rough figure I see that I need to draw 45 degree at A. Okay, so let me quickly construct 45 degree angle at A. Okay, so this is our 45 degree angle. So we have made our 45 degree angle. Now here I need to take 3 cm, right? So let me take 3 cm radius. So I have taken 3 cm radius with me. Okay, now let me cut this extended line from A at this. Now this is exactly 3 cm, so that's why this point of intersection will be my point D. Okay, now again I have not changed the radius, it's still 3 cm. Okay, from B also I have to take 3 cm, because if this is 3, this is also 3, and if this is 6, this is also going to be 6. Okay, so that's why from B also I'll take a radius, or I'll take an arc this way. Now from D I have to take 6, right? So let me take 6 cm. Okay, so I have taken 6 cm, and that 6 cm has to be drawn from D. So this is my D, and let me cut it here. Okay, now this point of intersection will be my point C. Okay, now let me quickly join all the vertices here. So after joining we get a parallelogram ABCD ready with us. Okay, so let me draw the parallel sides. So these two are parallel and these two are parallel. Okay, so we'll write okay, so we have constructed our parallelogram. Now there is a next part which says, if the bisector of angle DAB, so this is my DAB, so we need to bisect this. Okay, and the bisector meets DC, that is this line, at point P. So let us quickly draw the bisector of angle DAB. Now to draw bisector, we know that we will keep our compass here and here. Okay, so these two are the lines which are forming 45 degrees. So wherever it is forming 45 degree, we'll keep our compass at that point. So from here I'll take an arc, don't change the radius, keep it here and cut this line. Okay, and we will join this way. Okay, so this line, whichever line I have drawn, is my bisector. Okay, and this bisector meets DC at point this, right? And this point is known as my point P. Okay, question says, prove that angle APB, that is APB, that means I need to join this as well. So let me join that also. So after joining I'm getting this much, right? So we need to prove that APB, that is this angle, is a right angle. That is, I need to show that this is equals to 90 degree. Okay, now if you see here carefully, this angle, this angle, this angle, and this angle, if I add them I'll get a straight line, right? So let us quickly write this. Okay, so we know that which angle is this? DPA, that is angle DPA A plus angle APB. So this angle is angle APB, angle APB plus next is CPB. CPB will be equals to how much? 180 degree, because I'll get this angle, this full angle, and this full angle is known as straight angle whose value is 180 degree. Now let us try to search for Z kind of figure. Okay, so for example, here I see Z, right? So this is a Z, and here also we can see opposite Z, right? So whenever we see Z kind of figure, we always search for alternate angles. Okay, so here this one and this one are alternate angle. Okay, and this one and this one, they are also alternate angles, and we know that alternate angles are always equal. Okay, also since AP is the bisector, or this line is the bisector, this angle and this angle will be equal to each other, right? Okay, and since this full angle is 45 degree, what am I going to have? I'm going to have this angle and this angle equal to each other, and both of them will be equals to 22 and half, because half of this 45 is 22 and half. So this is also 22 and half, this is also 22 and half. Okay, now as I said, this one and this one, they are alternate angle, right? And what will be the value of both? If this is my 22 and half, this is also going to be my 22 and half. Yes. Okay, now if you see this triangle, what am I having? I'm having this angle equals to 22 and half, this is also 22 and half. So basically this is what kind of triangle? This is isosceles triangle. Okay, because two angles are equal, so that's why we call it isosceles triangle. So we know what is the value of this. So the value of this is turning out to be how much? This is turning out to be exactly 22 and half. This is also 22 and half. Now in an isosceles triangle, we have one more case, that is these two sides will be equal, and we know that how much is AD? AD is 3 centimeters. So let me write 3 centimeter out here. We know that AD is 3 centimeter. So that's why we are going to have this also equals to 3 centimeter. Is that clear? Okay, now here if this is 3 centimeter, see from here to here is 6 centimeter. That means from here to here is also 6 centimeter, but from here to here is 3 centimeter. That means this remaining side is also 3 centimeter, right? That means this is also 3 centimeter out here, right? This is 3 centimeter, so that's why this is also 3 centimeter. That means this triangle is there, this is also going to be isosceles triangle here. Okay, that means these two angles will be equal again, because these two sides are equal, no? So that's why these two sides or these two angles has to be equal. Okay, so we know one more case, that is this and this, they are also equal to each other, right? Because they are alternate angles. Okay, so these two are also equal, these two are also equal. So what is the meaning of this? This means that this BP, since this and this both are equal to each other, that means BP is also acting like bisector of this angle. Okay, so let us quickly see what is the value of this full angle. Okay, now we know that the opposite sides or the opposite angles of parallelogram are equal. That means from here to here is 45, that means this is also 45. Okay, and we have to find the value of this. Okay, so this will be nothing but this is 45, right? So if you add these two, you should get 180. Okay, so that's why this full angle is going to be how much? It will be equals to 180 minus 45. Okay, so 180 minus 45 is how much? So 180 minus 45 will be equals to 10 minus 45, right? 10 minus 5 is 5, so we have 17 left. 17 minus 3 is 17 minus 4 is 135. Okay, so the value of this angle is 135. Okay, so the half of this, because we know that this is BP is also a bisector. Okay, so we need to find the half of this, that is half of 135 will be how much? So it will be 67 and half. Okay, so basically we saw that This is 67.5, this is also 67.5, right? So let me write DPA. So DPA means this angle. So this angle turned out to be how much? This angle turned out to be 22.5 degree, right? Plus angle APB, we need to find this, plus angle CPB and CPB, that is CPB, that is this angle turned out to be how much? 67.5 degree, right? So this equals to 180 degree. Okay, so let us add 22 and 22 half and 67 and half. So if you add these two, how much will you get? So you will get 90 degree plus angle APB, right, which is 180 degree. Okay, next one is, we'll shift this out there. Okay, so we have angle APB equals to 180 degree minus 90 degree, which is nothing but how much? Which is 90 degree. So we need to show here that APB is a right angle, so that is APB is 90 degree. Okay, so hence we have proved it. Okay, so pause the video to note down. And one more thing, the detailed proof of this will be given in the description. Okay, dear students, let's have a look at our second question. Draw a parallelogram ABCD with the given data. That is this angle. This particular question is also similar to earlier question. Okay, so let me quickly do the first part. The second part we'll have a look at in detail. Okay, so our parallelogram is ready with us, so we'll write. Okay, so we are done with this. Now next part says, let AC, okay, AC, that means this line, and DB, that is this line, that is diagonals, meet in O. That means O is the point of intersection of diagonals. So let me quickly draw our diagonals here. Okay, so our diagonals are ready. So the point of intersection of diagonals is O. Okay, now next is, question says E is the midpoint of BC. So let us construct the midpoint. So midpoint, to construct the midpoint, we will take perpendicular bisector. Okay, so you know how to draw perpendicular bisector. So we'll take the radius slightly greater than the midpoint. Okay, and we'll draw an arc this way. So from here also we'll do the same. Okay, and we will join it. Okay, so this is my midpoint of BC and we call it E. Okay, so midpoint of BC is E. Okay, join OE. So let us join OE. So I have joined OE here. Okay, now question says, prove that OE is parallel to AB. So OE and AB are parallel to each other. That's what we need to show. Number two is, OE is equals to half of AB. So that's what we need to prove. Okay, so to prove this part, we make use of something called midpoint theorem, which we have not learned as of now. So we will learn the very same theorem, that is midpoint theorem, after few classes. Okay, so midpoint theorem says if there is a triangle ABC, okay, so if there is a triangle ABC, okay, now in triangle ABC, let me take midpoint of AB to be X, okay, and the midpoint of AC to be Y, okay, then this line XY will be parallel to BC. Okay, so according to midpoint theorem, there are two results. So result says XY is parallel to BC. Okay, and second part says XY will be exactly half of BC. Okay, so that's what is the result of your midpoint theorem. Now let us say apply the same midpoint theorem in this particular triangle, that is OAB. Okay, now we know that for this AC, okay, so we are looking at CAB, triangle CAB. Okay, so in triangle CAB, now we know that O is the midpoint of AC, right? So O is the midpoint of AC, right? And E is the midpoint of BC, right? So let us compare this triangle and this triangle. So this O is like X for me, okay, this A and C are same, this B and A are same, okay, this E is like Y, okay, this C is like A, as I said, B is like C. Okay, now if I compare these two triangles, O and E both are midpoint like X and Y, okay, so that means if I use midpoint theorem in this particular triangle, this is my XY, so this XY has to be parallel to BC, right? So using midpoint theorem, we say that OE is parallel to AB, right? This is my first one, so that's what we need to show in the first case. Now number two is XY, that is OE, will be exactly half of BC, that is this line, that is AB, right? So that's what we need to show in the second part. So hence we have successfully proved the cases. So pause the video to note down. Yesterday, that is in the part 4 of construction, there was a question on drawing regular hexagon, right? So to draw a regular hexagon, we saw our process, okay, but according to your syllabus, okay, you are not allowed to use that particular technique which you have seen in your part 4. Okay, so there was a mistake from my part, so I apologize for that. So the actual thing that you are going to do here will be shown in today's video. Okay, so let us see how to construct regular hexagon using the actual technique which is given in your syllabus. Okay, so what you need to do is each corner angle of your regular hexagon will be exactly equal to 120 degree. If you have drawn the hexagon, kindly take your protractor and measure each angle, so you will find it to be exactly 120 degree. Okay, so we need to construct here only 120 degree angles. Okay, so let us start with B. So at B we'll construct 120 degree angle. Okay, so I have made 120 degree angle here, right? Okay, now this side also has to be exactly 2.5, right? So that's why I'll take the compass, take the radius to be exactly 2.5 and cut this point, okay, and name this point as point C. So then A, B, this has to be C. So at C again I have to draw 120 degree angle. Okay, so let us quickly draw 120 degree at C also, and we'll repeat the same process. Okay, Okay, so finally what you're going to do is, this is my point F. Okay, so at last you need to draw a 120-degree angle, so you will directly join these two points. Okay, so this will automatically be equals to 120 degree. Okay, so that's how we draw our regular hexagon. So we write, so pause the video to note down. Okay, so there's a question on construction of rectangle. Okay, so question says, construct a rectangle each of whose diagonals measure 6 centimeter, and we know that the both diagonals of rectangle are equal to each other. Okay, and the measurement of both are given to be 6 centimeter, and the diagonals intersect at an angle of 45 degree. That is, angle of intersection of the diagonals of the rectangle is given to be 45 degree. So you will try this by yourself. That's why I've written homework out here, because we know that rectangle is also a parallelogram. Okay, and we have seen a construction of parallelogram where two diagonals were given and the angle of intersection of two diagonals were also given. Okay, so this question is similar to that particular question, so you will try this by yourself. Okay, thank you very much.